In this video, we're going to have a look at rational functions and what they look like, how to find the asymptotes, and how to sketch them. Okay, so a rational function is a function where we're going to have some sort of division or x's on the bottom line. If you ever see an x on the denominator of a fraction, we know it's going to be a rational function. And rational functions have an interesting look and shape about them because there's times where in the function we're going to have these random dotted lines which are actually asymptotes where the function doesn't exist. So we'll go through and find the asymptotes and intercepts of both of these examples and sketch them. So firstly, if we want to try and find the asymptotes of a rational function, we start with the vertical asymptote. Now the vertical asymptote can be found by finding the fraction part of the function, and we want to look at the denominator. And we want to make that equal to 0. So if we set this denominator of x plus 2 is equal to 0, we can then solve for x. And x will therefore be equal to negative 2. And the reason why we do that is because if x is equal to negative 2, think about what y will be, our function. Well, we will have 9 over negative 2 plus 2, and then plus 3. And negative 2 plus 2 is 0. And we know that 9 divided by 0 is undefined. We can't do that. So we're going to have an undefined answer for y, which is an asymptote. So that's why we let the denominator equal to 0. Okay, our horizontal asymptote. This is going to be our y equals equation. What we need to do is we need to look at our fraction part of our rational function, and we need to spot if there's any x's on the numerator, on the top line. And if there isn't, which is in this case, there's no x's, the horizontal asymptote, y equals, will be 0 because there's no x's on the top line, so it's just going to be 0. But then we need to consider if there is a vertical shift to our rational function, and that's a plus or minus, a constant at the end of our function. And if there is one, we need to add or subtract whatever that is, because that's going to shift our whole function up 3 units. So our horizontal asymptote will be 0 plus 3. So y will equal 3. So they are the two equations of our asymptotes, our vertical and horizontal. Okay, we also want to find our intercepts of our rational function. So let's start with the y-intercept. So y-intercepts can be found, or y-intercepts can be found when we let x equal 0. Now if we let x equal 0, we're going to get y is equal to 9 over 0 plus 2 plus 3. Now 9 over 2 is just as a decimal 4.5. We could add the 3, so we 7.5. So y will be equal to 7.5. And that will be our y-intercept. And that should be intercept. There's only ever one y-intercept. And x-intercept, we know we can find when we let y equal 0. So if we let y equal 0 of our function, we're going to get 0 is equal to 9 over x plus 2 and then plus 3. And the goal is to solve for x. So we can move the 3 over as a negative. Negative 3 is equal to 9 over x plus 2. And then we can multiply the x plus 2 up by negative 3. And we're going to get negative 3x and then minus 6 is equal to 9. And we can say negative 3x is equal to, and if we add the 6x over, over to 9, we're going to get 15. So x will be 15 over negative 3, which is negative 5. Okay, now once we have our asymptotes and our intercepts, we can sketch this. So let's just do a rough sketch down here. We know that we have y and x. Let's put in our asymptotes. Our vertical asymptote is when x equals negative 2. So if we go to when x is negative 1, negative 2, and that whole dotted line here is when x equals negative 2. So that's going to be our vertical asymptote. when x is equal to negative 2. Now our horizontal asymptote was when y is equal to 3. So y is equal to 1, 2, and 3. So if we extend that, that is our horizontal asymptote when y is equal to 3. Now let's put in our intercepts. Our y-intercept is at 7.5. So it's going to be up here somewhere at 7.5. This will just be a rough sketch. Actually, this might go a little bit higher. And so this will be 7.5. And we also know that the x-intercept is negative 5. So it's going to be somewhere about here, negative 5. Now with rational functions, we know we have this weird shape where we're going to have opposite sides, or it could be here and here. So we need to determine which sides it will be depending on what the intercepts told us. The intercepts told us that it goes through this point here at 7.5. So I know that it's going to have some sort of curve that looks like this, that will asymptote at this horizontal and asymptote at this vertical. And then we're also going to have one that passes through here and asymptotes and asymptotes. So it's a bit of a weird shape, but they're pretty lenient in the IB Math exams just by doing a rough sketch through these two key points. Okay, so that's the first example. I'll go through the second example using a very similar technique. So if we have a vertical asymptote when the denominator is equal to 0, so x plus 1 is equal to 0, so therefore x is equal to negative 1. We have found the equation of our vertical asymptote. Our horizontal asymptote, this is when y equals. Now I said in the first example, if there's no x's on top, it's going to be 0, and then we need to consider some positive shift. If there is an x on top, the horizontal asymptote, the equation is y equals, and it's the coefficient of the numerator x divided by the coefficient of the denominator x. So in simple terms, it's going to be whatever the number is in front of the x over whatever the number is in front of the x. So it will be 2 over, and there's an invisible 1 here in front of the x. So it'll be 2 over 1. And we do need to consider, is there a positive or negative shift happening here? And in this example, there is not. So we can just say y is equal to 2. Okay, our intercepts, our y-intercept, that is when x is equal to 0. So we have y is equal to 2 times 0 plus 4 over 0 plus 1. So y will equal 4 over 1. And our x-intercept, this will be when y is equal to 0. So 0 is equal to 2x plus 4 over x plus 1. Now to solve this, we just multiply the x plus 1 up by 0, which is just 0. So 0 will just equal the numerator, 2x plus 4. If I move the 4 over, it will be negative 4. And if I divide the 2 underneath, I'll get negative 2. So x will equal negative 2. Okay, so let's now sketch with what we know. So I have my y, my x, my asymptotes, I can put dotted lines. So when x equals negative 1, which will be here, so that's VA, when x equals negative 1, and my horizontal asymptote was when y equals 2. So that's my horizontal asymptote when y equals 2. I know that my function will pass through my x and y intercept, so 4 for the y and negative 2 for the x. So once again, I can then sketch my curve with a rough shape that passes throughout my points but asymptotes at my dotted lines. Okay, so this is an introduction. I highly suggest you practice a few IB questions on rational functions, but stick to these templates here of finding the asymptotes and the intercepts. Okay, good luck.